So at this point, we're like almost 200 pages into the textbook. We've learned a lot of math. To do these next problems, we're going to have to go back and pull out some of those concepts we've already learned. So remember when we had something like the nth root of a to the mth power? And we said, oh, you can write that as a to the m over n. And we introduced the idea of rational exponents. So you can take it from a radical form and you can write it in a rational exponent form. Okay, so that's one idea we need. And then remember when we were solving quadratic equations and we said, oh, if you have like x squared equals a, you can take the square root of both sides. But what did I always say? Don't forget the plus or minus, right? Okay, so that's true. Now, what if you had something cubed? Well, you can take the cubed root of both sides. So here it comes. Here's the cubed root of that side and the cubed root of that side. But you don't need the plus or minus. You only need the plus or minus if it's an even power, okay? So here you would just have x equals the cubed root of a. And the reason for that is because it could be positive or it could be negative, but you'll know by whatever a is, okay? All right, so here we have an example. We're going to solve this equation in a minute. But first what we want to do is recognize that this part, the radical part, that can be written like this. 3, that's the 3 right there, x to the 3/4 minus 6 equals 0. And that's that equation. We're going to solve it in just a minute. Okay. Here's the rule. If you have a to the m over n power equaling, b, then what you're going to do is you're going to raise both sides to the reciprocal, the n over m power, okay? But it makes a difference if m is even or if it's odd. Okay, so think of m as 2. Like if it were 2, that would mean you were taking the square root of both sides. So then you'd have to have the plus or minus. So if m is even, then a equals b to, plus or minus b to the n over m. But if m is odd, you don't need the plus or minus. Then a equals b to the n over m. Okay? So it's a little tricky there. It's a rule to remember. Like I would definitely put this on my note page for the exam. Okay. So if that numerator is an even number in the original, okay, then you got to have the plus or minus. So here you have a 3 for the numerator. So am I going to need the plus or minus? No. Okay, so this m is odd here. Now what about over here? Is m even or odd? It's 2, so m is even. Okay, so that'll just point that out as we do these problems. Okay, now let's go ahead and solve these problems. All right, so we've got 3x to the 3/4. I'm going to add the 6. You still want to get this part by itself, so equals 6. And then I'm going to divide both sides by 3, so probably not too shocking so far. And I get x to the 3/4 equals 2. Now what do I want to do? I want to raise both sides to a power. We decided that m was odd, so we don't need the plus or minus. And it'll be the reciprocal of that exponent. So I'm going to raise both sides to the 4/3. Okay. And then that's going to give me 2 to the 4/3. If I want it as a radical, which I think they're just going to be happy with 2 to the 4/3, but I could write the cubed root of 2 to the 4th power or the cubed root of 16. So I'm not sure which way they want it. If they want it this way, I think I would leave it that way. but maybe they want this. So I think this one does. All right, let's find the other problem. Okay, and we didn't need the plus or minus on that one. So now we have this x to the 2/3 there. Okay, that's great. But we have these fractions, so I need to add that 3/4 over. So I'm going to have a negative 1/2 plus 3/4. And that's going to be x to the 2/3. Okay. Now I'll have to get common denominators because of the fraction. So minus 2/4 plus 3/4 x to the 2/3. So x to the 2/3 equals 1/4. Okay, so now we got the x to the rational exponent by itself. Now we have to raise both sides. So we're going to raise both sides. We have to do the reciprocal, 3/2. But this time, we'll have the plus or minus. Okay? All right. On the left-hand side, I didn't really show this before, but that just equals 1, right? Power to a power, you're multiplying them. That's why we're doing this, to make it just be x. See, the same thing happens over here. You get 12 over 12, that's just 1, and so you have x. X equals. Okay. So now on the other side, I'm going to have plus or minus. I'm going to write this in the radical form. So it's the square root of 1/4, I'm ahead of myself, cubed. Now I am going to do that because I can simplify it. So I'm going to have x equals plus or minus, and then the square root of 1/4 is 1/2, but I have to cube that, so x equals plus or minus 1/8. So using our exponent rules, I'm pretty sure now that they're going to want it this way with the radical, I think. So we'll see. All right. Actually, I looked in the book and they did leave it that way. And then they got a decimal approximation, so you don't have to do that unless they ask for a decimal approximation.